Alright, ladies and gentlemen, so in this video we are going to start diving into how to solve logarithmic equations. So the last video was all about exponential equations, and today in this video we're going to start diving on into how to solve logarithmic equations. So let me ask you, what do we do to all of these exponential equations in order to solve for x? Well, we did something to get x by itself, right? We either natural logged both sides or we logged both sides of the equation because it's the inverse of the function itself. Well, now we are going to what we call exponentiate both sides of the equation, or quote unquote sometimes both sides of the equation. And we did that in the very first example for a brief little check. So we're going to start off pretty basic here. We have a logarithmic equation of the natural log of x equals 2. So we want to exponentiate both sides. Well, because we are dealing with the natural log, we are going to exponentiate it using the natural base of e. And so this is when I say we're going to quote unquote e both sides of the equation. So for part A, we're going to e both sides of the equation. So I'm going to say e to the natural log of x equals e to the second power. Again, why do we do this? Because we know that e to the natural log of x, because those are common bases, just equals x. So it equals e squared. And you can leave it like that. Guys, it's perfectly fine to leave it like that. So x equals e squared. Game, set, match. What about for the log with a base 3 equals log 3 of x plus 7? What happens here? Well, the goal is to exponentiate both sides. However, you got to ask yourself, do you need to exponentiate both sides? What is in common on both sides of this equation? It's already exponentiated for you because it has the same base in base 3. So if those same bases are going to be equal to one another, the only way this happens to be a true statement is if 5x minus 1 equals x plus 7. This is a basic algebra. 4x equals 8 or x equals 2 when it's all said and done. Alright, so be on the lookout for both different types of problems that you have. Let's keep pushing on. Solve the following equation. Once again, remember, your goal is to get x in the exponent if not using a simple log identity property. Okay? So let's go back. Part B, simple log identity property. This example, alright, our goal is to get x in the exponent so we can, quote unquote, exponentiate it. So I want to get x by itself. 2 natural log of x equals -1 first and foremost. Then I want to go ahead and divide, all right, both sides by 2. And so now this is the point in time where I can get x out of the natural log by eing both sides. Because now I get that x equals e to the -1/2 power. Now, if it does go ahead and say approximate or anything like that, we can roughly put this on out to 0.607 as well. All right, so we want to e both sides of the equation. All right, guys, so let's go over the first two. I challenge you, pause the video right now, guys. See if you can solve the first two on here on your own. And then we'll have a little brief pause to go over 3 and 4. So pause it right now. Do it. All right, number 1. Let's take a look here. What do we think? Well, once again, we want to go ahead and to think about exponentiating when we can exponentiate, right? So in an example like this, where we have natural log equals x to the -3rd, well, I want to e both sides of said equation. And then that drops down to just x, or e to the -3rd. Number 2, log with a base 10 of x equals 6. All right. So how are we going to go about solving with a log base 10 like so? Well, what are we trying to do here? Once again, we're trying to somehow get x into that exponent. Well, just like we would e both sides of the equation, well, it's kind of the same thing. We are going to raise both to the power of 10 because 10 to the log of base 10 of x will give us x, and x will equal 10 to the 6th power when it is all said and done. All right? Wanted to go back just real quick and see exactly our inverse property here up top. All right, so we're going to raise it to that 10, or 10 to the log, so we can get x by itself. All right, guys, so now once again, pause the video, give number 3 and give number 4 a shot on your own before we go on over them. Do it. Pause it right now. All right, let's take a look. What do you guys think? So first and foremost, I want to get the 2 on the left or the right-hand side, so I'm going to subtract it, and then I want to go ahead and divide and make this going to be a negative 4 over 3. So once again, guys, with natural log, I want to e both sides. So take the base e, raise each of these, making an exponent. X equals e to the negative 4/3 power. And then finally, what about number 4? So for number 4, I first and foremost want to go ahead and move that 5 over. So I'm going to go ahead and make it a division. So log base 10 of x minus 2 equals 11 over 5. And now I need to get the x out of there, but I need to exponentiate it. So I want x in the exponent. So I make that 10. I put a 10 there, so we're going to raise each of these now with a base of 10. So that means x minus 2 is 10 to the 11/5 power. Add the 2 on over, and x equals 10 to the 11/5 plus 2 in this example. All right, ladies and gentlemen, that's going to wrap it on up here for today. All right. And as we wrap it on up, I've got one final one I want you guys to give a shot on your own. All right. Before solving the equation below, I have given you the domain of this because I want you to think about what the possibilities are. Okay. Remember what it means for the log. You have to keep this log greater than 1 because you don't want 0 in that logarithm. Now, go ahead and take this and solve the equation for x. Give it a shot on your own. Go over it first thing. We're on to the next one.